So welcome back to CSE Notes. I'm back with a new video tutorial. So today's topic is heap sort. Heap sort is actually a comparison based sorting technique. There are two types of sorting technique, comparison based and address based. Here heap sort is actually a comparison based sorting technique where we compare the values and according to the requirement the greater and the lesser values will be placed into its suitable position. So before going to the algorithm of heap sort, we want to revise some heap concept. Once we can understand the heap concept or heap mechanism, the algorithm will be easier for us. Firstly, what is heap? A heap, it can be defined as a complete binary which is represented using array or sequential representation. So heap is actually a complete binary tree. So what is complete binary tree? So complete binary is that kind of binary tree where all the levels except the last level have the maximum number of nodes, and all the nodes in the last level, that means the leaf nodes, should appear as far as left possible. That is actually complete binary tree, and the heap of is a kind of complete binary tree. Then heap can be categorized into two types, max heap and mean heap. So max heap is used in ascending order sorting, and to sort a array in descending order the mean heap is used. So here we are going to sorting here we are going to sort an array in ascending order. So the heap will be used. What is max heap? Heap is actually called a max heap and descending heap if all the nodes of the tree having a value greater than or equal to the every child of that node. That means all the parent node will have a value greater than or equal to the every child of that parent node. This is also known as heap property. So we can see from the definition, we can tell that the max heap the root will keep the largest value. As you can see from this max heap example, in each level, that means in this level 60 is the maximum element of this parent child relationship, and 90 the maximum value of this parent child relationship. 90 is greater than left child and also greater than right child. That means in this parent is greater than its every child. This 60 parent is greater than of every child. Then in this level 100, it is also greater than its left child and right child. That means the root will keep the largest value. From this max heap example you can see. Then we will see that how a tree is stored in a how is a binary tree is stored in a array. So the mechanism is the left child index will be calculated as 2 into parent index, and the right child index will be calculated as 2 into parent index plus 1. Suppose here root is 100, so the index is 1 of the index of 100 is 1. Then the left child 90 will be calculated as, the index for 90 will be calculated as 2 into parent index, that means 2 into 1, that means 2. And the right child index will be calculated as 2 into parent index plus 1, that means 2 into 1 plus 1, that means 3. The index of 60, the right child will be 3. And according to this same mechanism, the index of 80, 70, 50 and 40 will be calculated. So now we are going to the algorithm of heap sort. So before starting the algorithm of heap sort, we want to see what this algorithm does actually. So this algorithm firstly build a max heap. So after building the max heap, the root will keep the largest value. So we have to exchange the root with the last element, because the root will keep the largest value. So largest value will go to the last position in ascending order sorted elements. So the root will be exchanged with the last element. Then discard the last element and reheap by using the root to maintain the heap property, because once we have found the last element, that means the maximum element, then we have to discard that element, and we will reheap by using the root to maintain the heap property. And this exchange root and last position and discard the last element and reheap by using root to maintain heap property. These two steps will be continued to sort the elements. So we are going to the algorithm of heap sort. First, in the very first line, we can see heapify an is as a function is called. So this heapify function actually build a max heap, and it is called with a, that means the array, and a is the number of elements. It will be called using these two arguments, and it will be called in this position algorithm heapify a comma n. In this heapify function, we can basically see that a loop is rotated and an adjust function is called. A loop is rotated from n by 2 to 1 and step minus 1, that means it is decremented. Why this loop is rotated? Because to maintain build the max heap, we can see that from n by 2 to n, that means if in any binary tree all the leaf nodes will start from n by 2 plus 1 to n, will always satisfy the heap property, and we have to build a max heap from n by 2 position to 1, decrementing the loop. That means in a 7 vertices or 7 nodes tree, the to build a max heap, we will start from the 3 position, 7 by 2, floor value of 7 by 2, that means 3 for 3, then for 2, and then for 1 position or 1 index node. So we will see the heapify function. It will start from n by 2, that means if we can start with n equals to 7, that means the n the floor value of n equals to 7 will be n by 2, the n by floor value of n by 2 will be 3, and it will be called for the adjust function will be called for 3, 2 and 1 by decrementing the loop by 1. So firstly for 3 it is calling the adjust function. So adjust function, a the array, I is the index, that means 3, and n is the number of elements. So we'll go to the adjust function. So basically where it is passing the parameters, a the array, I is the index of the parent node, from where we are building a max heap, n is the number of elements. So item, first in the first line, item is equals to ai, that means item is item is storing the element the parent node, the first parent node for which the adjust function is called. That means item will hold the 50 value, item will hold the 50 value for the first calling of adjust function. Then j will hold the left child of 50, that means left child of this parent, that means it will hold the 60. And in this mechanism, firstly what is actually done by this while loop and this ag by 2 equals to item, we will tell that we are building a max heap. That means the parent, this in this position the parent will hold the maximum value which will be greater than these two child. That means it can be done by this mechanism, that we will find the maximum child from this two child, we will find the maximum child, and we will check that maximum child is greater than that parent or not. If the maximum child is greater than that parent, then we will interchange the parent with the maximum child. So this is done by this while loop and this ag by 2 equals to item, we will see that. So while j less than equals to n, j is equals to 2 I, that means the left child index, so that should be less than equals to n, then this loop will rotate. If j less than n means, why j less than n? Because j will hold the left child index, and we are doing an operation j plus 1. If j less than n, then the aj plus 1 will hold a valid value. So this j less than equals to n should be satisfied, and aj less than aj plus 1. Previously my j is 2 into I, that means left child index, and if we can see that aj, that means left child index, is less than equals to right child index, that means left child less than right child, that means right child is greater than left child, then we will increment the j index, because j will hold the maximum value child index. If the right child is holding the maximum value child, then j will be incremented to j plus 1, and it will keep the index of right child, because right child is the maximum value child. But here we can see 60 is the left hand side left child, and 40 is right child. So 60 less than equals to 40, this loop this if is not satisfied. So j will remain to 6 position, that means we will hold the index of 60. Then we will check for this maximum value child is greater than or less than the parent node. If this parent is already greater than this maximum value child, we will break the loop, and if not, then we will replace we will interchange this maximum value child and parent. How we can see it? if the item what is item here? Item is actually the 50, the parent the parent node the adjust function is called, that is 50. If item greater than aj, that means that aj means 60, so 50 is already greater than 60, that means it is already a maxive, then no need to do anything, so we will break the loop. If not, that means the parent is less than that maximum value child, then we will interchange this maximum value child and this parent. How? Currently my j is 2, so aj by 2, that means the floor value, we will take the floor value aj by 2, that means uh, in 3 position aj by 2, 6 by 2, that means in 3 position we will store the maximum value child, that means 60 we will store in 3 position, that means in parent position we will store the maximum value child, that means 60 will go to the 3 index, and we will replace this 50 in 6 position, but in another way. How? Here we are doing j equals to 2j, that means currently my j is 6, and we will do j equals to 2j, that means 2 into 6, that means 12, that means j equals to 12, so 12 less than equals to n, 12 less than equals to 7, no, this does not satisfy, so then aj by 2, that means a 12 by 2 equals to item, that means a 6 equals to item, that means this 50 will go to the 6th position. And why we will do that, this j equals to 2j and aj by 2 and equals to item, we will see for this 80 parent. So by using this property, using this while loop, we can build for 50 parent, we can build the maximum of 50 parent for 70 parent. So after building this two parent maxive, we can see here the 60 will be the parent after building the maxive, and for here 100 is the maximum element, that means the parent node. So currently my currently I have two maxive for 60 and for 100. Then for the third time, this adjust function will be called for the 80 value. So that means index will be 1. So item will hold the ai, that means 80. Then j equals to 2i, that means the index of left child of 80, that means index of 100. Then while j less than equals to n, yes, 2 less than equals to n, then j less than n, same concept we have told before. Then aj less than aj plus 1, that means left child less than right child, no, left child already greater than right child, then j will not be incremented. Then item greater than aj, item means 80 greater than aj, that means left child greater than left child, no, that means break will not be satisfied. Then aj by 2 equals to aj, that means aj by 2, that means 2 by 2 equals to 1. In the 1 position we will store the value 100 aj, that means left child. So in the root position we will storing the maximum value. Then we can store this 80 value directly in this position, in 2 position, but it will break my this maximum heap property. So we have to check for the lower level, we have to check for lower level, this is the important part for here. So we have to check for the lower level, we have to maintain the lower level maxive property, so we will go to lower level by j equals to 2j. So in j equals to 2j, that means j equals to 2 into 2, that means 4, so we are going to lower level. 4 less than equals to 7, yes, so by using this 4 less than equals to 7, using the same algorithm, we will reheapify this, that means we will maintain the heap property of this node. And after seeing that this 80 will go to this 90 position, and this 90 will go to this position, and using this aj by 2 equals to item. So using this we can develop the algorithm, and the adjust function will be called 3 times. Then this is done, heapify build a maxive is done. Then we will here in the heap sort function we will call a this loop is actually implemented I equals to n to step minus 1. That loop will be continued for 6 times. For here step minus 1, that means it's decrementing. So maxif is the building of maxif is done. Then we have to exchange the root with the last element by using this exchange. Temp equals to a1 equals to ai equals to temp. That means in temp we are storing the root element, and we in the root element we are storing the last element. Here n is the ai equals to n. That means we are storing in root position the first last child, and in the last position we are storing the root value. That means the maximum value. Why? Because after building the maxif, the root will give the largest value. So we will go exchange the root with the last element. Then for that we have to reheapify this heap tree, and using this adjust a1 comma I minus 1, a comma 1 comma I minus 1. So if you by using root discarding the last element, how we are discarding the last element? Using this for I minus 1, because currently my n is I is n, that means 7, and we are discarding how n minus 1, that means 7 minus 1. That means using 6 element we are calling the adjust function, and it will do the same job we have explained before to maintain the heap property of the heap. By using this algorithm, it will be doing us for it will sort the array, and this is the actually the algorithm. We will see the code. Now we have written the code, and we will see the code here. The code is actually same as the algorithm. We will see once. First we are going to the main function. In a20 is the array, then n is the number of element, n equals to input. We have input function to take input. We are passing a input function. Here we are taking the number of element, we are taking the elements, and we are returning the n, the number of elements. Then heap sort function is called a comma n. We are going to the heap sort function. First line, in the second line we are building the maxif. Then same as the algorithm, we are building the maxif. Then we are exchanging the root with the last position, and we are reheapifying the we are reheapifying the heap tree using this adjust function, and we are discarding the last element, and we are reheapifying the heap tree using this adjust function. We have seen that in the algorithm, so no need to explain further. This is the code you can see, and this document will be available in our official website. So thank you. And this is the channel CSC Note. You can subscribe for the latest and this kind of video tutorials. So thank you again.